In last class, we completed up to question number 8 in exercise number 1.1 in the chapter Relations and Functions. Ninth problem is the homework problem. I want you to try that problem your own. I hope by this time you understand how to check reflexive relation, symmetric relation, transitive relation. In this 10th question, total 5 bits are there. This is the best example to check whether you understand all the definitions of reflexive, symmetric, transitive or not. What I will say, if you are good in the definitions of reflexive, symmetric, transitive relation, and if you know how to check those relations, you please pause this video, take the college material, take the question and try it your own. You see, what is this first bit in this 10th question? Give an example of a relation which is symmetric but neither reflexive nor transitive. Give an example of a relation. They are asking you to give an example. So here I am going with my own examples in all 5 bits. So what answer I will do here, what answer is there in our college material, what answer you will write, they may vary because they are asking to write their individual example. Give an example of a relation which is symmetric but not reflexive, not transitive. So this is one of the best question to check whether you understand reflexive, symmetric, transitive relation or not. Okay. First bit is like this. We need to write a relation which is symmetric but not reflexive, not transitive. Okay. I considered a set A like this 1, 2, 3. It is not compulsory you also take 1, 2, 3. You can take 4, 5, 6. You can take -1, -2, -3 like that. They are asking to give an example. That's why simple example I taken set A like this. And R is a relation from A to A. Like that I considered R is a relation from A to A. That means whatever ordered pairs I'll write in the relation, first element must be in set A, second element also must be in set A. Right, you know all these things. By this time you must be good in all these things, right? Now I'll write one relation of my own which is symmetric but not reflexive, not transitive. Okay, so I considered I written a relation like this. You see here they are saying not reflexive now. That's why I not included 1, 1, 2, 2, 3, 3 like that. Okay, and they are saying that this is a symmetric now. So that's why by keeping the question in mind, I written this relation. When you can write like this, when you are good in all 9 problems what we did till now in this exercise, right? I written a relation like this. You observe first element, second element both are there in set A. Yes, both are there in set A. So it is a relation from A to A. Now you need to check this relation is now you need to prove that this relation is not reflexive. Okay, I'll go with reflexive property. What is reflexive property? For any element in set A, for example, if I take x in set A, order pair x comma x must belongs to the relation. See here I taken 1 is there in set A. Order pair 1 comma 1 is there in this relation? No, it is not there. Because of this reason, I can say that this relation is not reflexive. And one more point I am specifying in all the videos, when it is not reflexive, not symmetric, not transitive, writing answer is very easy with counter example. When it is reflexive relation, you have to write the answer carefully. When it is symmetric relation, when it is transitive relation, you have to write answer very carefully. And you see in this 10 questions total, in this 10th question total 5 bits are there. Na? In these 5 bits you will get more clarity how to write the answer, right? Okay. So clearly this relation is not reflexive because if I take 1 in set A, 1 comma 1 not in this relation. So I written same thing here. Therefore R is not reflexive. Okay, and I need to give an example which is symmetric. Okay, what is symmetric property? First, I'll take an order pair A comma B in the relation. I'll check order pair B comma A is there in the same relation or not. First, I'll take an order pair A comma B in the relation. I'll check that the order pair B comma A is there in the same relation or not. How to check? You take first 1 comma 2. 1, comma 2. What is the reverse of this? 2, comma 1. Order pair 2, comma 1 is there in this relation? Yes, it is there. Okay. Now you come to this one. Order pair 2, comma 1. What is reverse of this? 1, comma 2. Order pair 1, comma 2 is there in this relation? Yes. That means for every order pair A, comma B in this relation, the order pair B, comma A is there in this relation. So this relation is symmetric relation. You observe here how I written the answer. How I written? I not written 1, comma 2 belongs to R, implies 2, comma 1 also belongs to R. Therefore R is symmetric. I not written like that. When it is symmetric, you need to follow the general pattern. You cannot give one example and you cannot say that it is symmetric. Okay. For any order pair A, comma B in the relation, the order pair B, comma A also there in the relation. Therefore this relation is symmetric relation. I hope you are understanding. They are asking you to give an example which is symmetric but not reflexive, not transitive. Now two things are over. Reflexive, it is not reflexive. Okay, symmetric, it is symmetric. Now they are asking to show that this relation is not transitive. Okay, not transitive. Not transitive. First you find a pair of order pairs A, comma B, B, comma C. A, comma B, B, comma C. You'd see 1, comma 2, 2, comma 1. You see A, comma B, 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 comma C. 1, comma 2, 2, comma 1. That means you are able to identify A, comma B, B, comma C in this relation. What is A, comma C? A, comma C. What is A, comma C? A, comma C is order pair 1, comma 1. You observe this relation. In this relation, order pair 1, comma 1 is there? No, order pair 1, comma 1 is not there. That means we are able to identify A, comma B, B, comma C in the relation, but A, comma C is not in this relation. So this is enough to say this relation is not transitive. See, when it is not transitive, I given an example. So this relation is not reflexive, not transitive, but it is symmetric. So this is the best example. What they are asking in this, give an example which is symmetric but neither reflexive nor transitive. So finally what I will conclude, therefore I will write here, therefore R is symmetric but not reflexive, not transitive. I not written here, you please write. Therefore R is symmetric but not reflexive, not transitive. Now we will move to second bit in this. You see the second bit in this 10th question. Give an example of a relation which is transitive but neither reflexive nor symmetric. Here what answer I am writing, what answer is there in our college material may vary. I am giving my own example. Like this you can also give your own example in case if you are very good in this symmetric definition, reflexive relation definition, transitive relation definition. Okay, I taken set A like this. R is a relation from A to A. R is a relation from A to A, and the relation I define like this by keeping the question in mind. They are saying that this relation is transitive but neither reflexive nor transitive. I written a relation. They are saying it is not reflexive. Na? So I'll keep in mind 1, comma 1, 2, comma 2, 3, comma 3 not present in this. Here 1, comma 1 is there but 2, comma 2 not written. You can check here. So by keeping, I written this relation by keeping the question in my mind. You can write like this when you are good up to question number 9 in this exercise. Okay. I written a relation like this. Now I'll go with the reflexive symmetric transitive order wise. I'll check that whether it is this example is satisfying this condition or not. Okay. First thing, in this 1 is there. In this set A, 1 is there. Order pair 1, comma 1 is there in this relation? Yes, order pair 1, comma 1 is there. From this, can I say it is reflexive relation? No, you cannot say like that. You need to check for every element in set A. For every x belongs to set A, order pair x, comma x belongs to the relation. Then only we say that that relation is reflexive relation. 1, order pair 1, comma 1 is there. Very good. Now you need to check for 2. You take 2 in set A. Order pair 2, comma 2 is there in this relation? No, it is not there. So because of this reason, I can say that this relation is not reflexive. See here, I taken 2 in set A. Order pair 2, comma 2 does not belong to this relation. Therefore, I can say that R is not reflexive. See, when it is not reflexive, I given an example. Okay. Now I'll go with symmetric property. As per the question, we need to show that it is not symmetric. Okay. What is symmetric property? You will take an order pair A, comma B, and you will check for an order pair B, comma A. See here, order pair 1, comma 1. I already discussed in earlier problems. For the order pairs order pair 1 comma 1, order pair 2 comma 2, order pair 3 comma 3, order pair A comma A. These order pairs always satisfy symmetric property. 1 comma 1, what is the reverse order of 1 comma 1? 1 comma 1 only, like A comma B, B comma A. 1 comma 1 reverse order is 1 comma 1, 2 comma 2 reverse order is 2 comma 2. So for such order pairs, symmetric property always holds good, no need to check. For this order pair 1 comma 1, order pair B comma A is also 1 comma 1. So symmetric property holds good for this order pair. Okay, now you see 1 comma 2. For this order pair, you need to check 2 comma 1 is there in this relation. See, 1 comma 2 is there in this relation. 2 comma 1 is there in this relation. No, 2 comma 1 doesn't belong to this relation. Because of this, I can say that this relation is not symmetric. See here, what is the definition of symmetric property? For every order pair A comma B in the relation, the order pair B comma A must present in the same relation. Here 1 comma 2 is there in this relation. 2 comma 1 does not belong to this relation. That's why I can say that this relation is not symmetric. Here, suppose in this 2 comma 1 is there. Suppose you written 2 comma 1. Can I say it is symmetric? No. You need to check for other order pair. Suppose you take 2 comma 3. For 2 comma 3, 3 comma 2 is there? No. Then also it is not symmetric. I hope you are understanding what I am saying, right? Now go to the transitive property. How to check the transitive property? This is the best example to check the transitive property. Listen carefully. How to check the transitive property? First, you need to find out a pair of order pairs like A comma B, B comma C. Here, how to check such pair of order pairs? You see here, you take first order pair. It is 1 comma 1. It ends with 1. Now you find out other order pairs in the same relation which starts with 1. See, this ends with 1. You identify other order pairs which starts with 1. See, this starts with 1. This also starts with 1. Okay, first I'll take these two. You observe these two order pairs. They are of the form A comma B, B comma C. Catch this point. A comma B, B comma C. What is A comma C? A comma C is 1 comma 2. Order pair 1 comma 2 is there in this relation? Yes, here it is. Okay. Now you consider this and this. See, this one and this one. 1 comma 1, 1 comma 3. What you identified? They are in the form of A comma B, B comma C. 1 comma 1, 1 comma 3. What is A comma C? A comma C is 1 comma 3. In this relation, order pair 1 comma 3 is there? Yes, here it is there. Okay, so I verified with this order pair. Now you come to the second order pair, 1 comma 2. Now you check what order pairs are there which starts with 2. This starts with 2. That's it. This ends with 2. Here I am checking for this order pair. As it ends with 2, you check for another order pair which starts with 2. Here this starts with 2. That means you are able to find A comma B, B comma C. A comma B, B comma C you identified. What is A comma C? A comma C is 1 comma 3. Try to understand. 1 comma 3. See, A comma B, B comma C is there. A comma C is 1 comma 3. In this relation, order pair 1 comma 3 is there? Yes, it is there. Okay, now I checked for this order pair, this order pair. Now come to third one. You see, this ends with 3. Now you identify any other order pair which starts with 3? No. Okay, you see here, this ends with 3. Now you check any other order pair in this which starts with 3? No. So I checked for every pair of A comma B, B comma C, A comma C exists or not. I identified 2 such pairs. 3 such pairs. One is 1 comma 1, 1 comma 2. Second one is 1 comma 1, 1 comma 3. Third one is 1 comma 2, 2 comma 3. In all 3 cases, A comma C present in this relation or not? Yes, present in this relation. That's why this relation is transitive relation. Here important point is how I'll write the answer for this. This I cannot give an example. See, 1 comma 1, 1 comma 2 belongs to R implies 1 comma 2 belongs to R. That's why this relation is transitive relation. Like that I cannot write. I hope you are understanding. You see how I written the answer. See, general pattern I followed. For every pair of A comma B, B comma C in the relation, you take any such pair A comma B, B comma C in the relation, A comma C present in the given relation. Yes, present in the given relation. How do you know this? Just now we checked. Just now I checked, total 3 cases arised. In all 3 cases A comma C belongs to this relation only. That's why the relation is transitive. You identify here, when the relation is transitive, you have to write the answer carefully. When the relation is not reflexive, not symmetric, not transitive, giving answer is very easy. Just we'll give the counter example. We'll say because of this reason it is not reflexive, not symmetric, not transitive. Try to understand why I am specifying this point again and again. This exercise, this chapter is not very easy. 60% of the students, they may feel it is easy, but for 40% of the students it is difficult. Maybe it may vary. 40% may feel easy, 60% may feel difficult. But it is easy to the person who understand the concepts, who practice more examples related to the definitions. They'll enjoy this chapter without any doubt. Now, we'll move to third bit in this. See, what is the third bit? Give an example of a relation which is reflexive and symmetric, but not transitive. See, these are the examples of my own. What answer I am writing here, what answer is there in your college material, what answer, if you want to do this problem your own, what answer you will write. All the things may vary, but make sure whatever the example you are giving, they are satisfying given condition. In case if you are unable to write your own example, then just follow this. I find out these are the easy things, right? First, I taken set A, and R is a relation from A to A. I consider these two things. You can change these things if you want, right? And I retain this relation just keeping the question in my mind. What they are saying? They are saying reflexive, na? As they are saying reflexive, and I considered set A as 1, 2, 3, I'll make sure that the order pair 1, 1, the order pair 2, 2, order pair 3, 3 present in this relation, because I need an example which is reflexive, because set A contains 1, 2, 3, 1, 1, 2, 2, 3, 3. I hope you understand what I am saying now, right? Okay. Now, they are saying it is symmetric also. So you know that for symmetric property, for this order pair we won't check symmetric property because it always holds good. The order pair 1, 1, reverse also 1, 1. The order pair 2, 2 for this symmetric property always holds good. No need to check for such order pairs. Suppose if I take 1, 2, I'll make sure I'll write 2, 1 this. 2, 1 in this relation, because I want an example which is symmetric. If I written 1, 2, definitely I'll write 2, 1. If I written 2, 3, definitely I'll write 3, 2. See, 2, 1, 1, 2, 3, 2, 2, 3, because I need an example which is symmetric. They are saying it is not transitive. As they are saying it is not transitive, I'll find out A, B, B, C in the relation, and I'll make sure A, C not in this relation, because I need to give such example. I hope you are getting the point what I am discussing, right? By keeping all those things in my mind, I written this relation, right? You can write this relation your own when you are good in the definitions, when you are practiced many problems in this related definitions. Okay, first thing, I need an example which is reflexive. You see here 1 is there in set A, 1, 1 is there, very good. With that I cannot say, I need to check for every element in set A. 2 is there in set A. Order pair 2, 2 is there in this relation? Yes, it is there. 3 is there in set A. Order pair 3, 3 is there in this relation? Yes, it is there. Therefore, this relation is reflexive relation. See here, when it is reflexive, how I am writing the answer? I am not giving an example. For any A belongs to A, order pair A, belongs to R. Or else you can write like this also. For any X belongs to A, order pair X, X belongs to the relation. It's your choice, right? So, the reflexive property is satisfied by this relation. Therefore, this relation is reflexive relation. Now, I need an example which is symmetric, right? Okay. So, observe the given relation. You take 1, 1. For this order pair, we won't check symmetric property because it always holds good. For this also symmetric property, you see here 1, 2. 2, 1 is there in this? Yes, 2, 1 is there. 2, 3. 3, 2 is there in this? Yes, it is there. 2, 1. What is the reverse of this? 1, 2 is there? Yes, it is there. 3, 2. 2, 3 is there in this? Yes. That means what happened? For every A, B in the relation, B, A also present in this relation. You understand, try to understand how I written the answer. I have not written that 1, 2 belongs to R implies 2, 1 belongs to R. That's why this relation is symmetric. I have not written like this. When it is symmetric, when it is reflexive, when it is transitive, you have to write answer very carefully, right? For any A, B belongs to R, B, A also present in that relation. Therefore, this relation is symmetric. I hope you got this point. Now what they are saying in this, they are saying give an example which is reflexive symmetric but not transitive. See, but not transitive means you need to identify a comma b, b comma c such that a comma c not in this. You see here 1 comma 2, 2 comma 3, 1 comma 2, 2 comma 3. When it is not transitive, writing answer is very easy. I am saying again and again, because I can, if I found out one example which is not satisfying transitive relation property, then I can say, see here 1 comma 2, 2 comma 3. I am able to find a comma b, b comma c. What is a comma c? A comma c is 1 comma 3. 1 comma 3 is there in this 1 comma 3? No. That means what happened? 1 comma 2 is there in this relation, 2 comma 3 is there in this relation, but 1 comma 3 does not belong to this relation. That means what happened here? Transitive property fails. Therefore, R is not transitive. I hope you understand what I am saying. Therefore, this relation is symmetric and transitive. Symmetric, reflexive and symmetric, but not transitive, right? Next, fourth example. Give an example of a relation which is reflexive and transitive. But not symmetric. Okay, I am giving my own example. What answer is there in college material? That may vary. What answer is there in another notebook? That may vary. If in case if you do this problem your own, that answer also will vary with this answer. I just consider set A like this 1, 2, 3, and R is a relation from A to A. I written this relation by keeping the question in my mind. See here, as they are saying it is reflexive, I consider set A as 1, 2, 3 now. I need reflexive relation, so definitely I will include 1, 1, 2, 2, 3, 3. And they are saying it is not symmetric. So here 1, 2 if I write, I'll make sure 2, 1 is not in this. 2, 1 is there in this? Not there. So I'll keep that in my mind. I'm writing this relation by keeping the question in my mind, right? Now I need a relation which is transitive. That means I'll make sure that for every pair of order pairs A comma B, B comma C, A comma C is there in this relation. So by keeping all those things, I written this relation. See here. 1 is there, I taken 1 in set A. 1 comma 1 is there in this relation? Yes. 2 in set A. 2 comma 2 is there in this relation? Yes. 3 taken in set A. Order pair 3 comma 3 is there in this relation? Yes. So for every x belongs to set A, order pair x comma x belongs to the relation. Reflexive property satisfied. So you see, when it is reflexive, how I written the answer? For any A belongs to A, order pair A comma A belongs to R. Therefore, this relation is reflexive. I hope you understand what I am saying. Now, symmetric property. See, as per the question, I need an example which is not symmetric. Okay, you see here in this relation 1 comma 2 is there, but 2 comma 1 is not in this relation. So because of this, I can say it is not symmetric. When it is not symmetric, giving answer is very easy. See, 1 comma 2 belongs to R. For 1 comma 2 belongs to the relation, the order pair 2 comma 1 does not belong to the relation. Therefore, the relation R is not symmetric. Now, I need an example which is transitive. Transitive means you have to check very carefully. When it is transitive, you have to check very carefully. Now what I'll do, I'll check for first order pair. You see, this ends with 1. Now you identify which begins with 1. Other order pairs which begins with 1. This I'm checking transitive relation for this order pair. How to check? First, it ends with 1. Now you identify the other order pairs which begins with 1. See here, this begins with 1, this begins with 1. First, I'll check this order pair and this order pair. 1 comma 1, 1 comma 2. What is order pair A comma C? 1 comma 2. Order pair 1 comma 2 is there in this relation? Yes, it is there. Now 1 comma 1, 1 comma 3. What is order pair A comma C? A comma C is 1 comma 3. In this order, in this relation, order pair 1 comma 3 is there? Yes, it is there. So with this, I checked with all other order pairs. Now come to this. This ends with 2 now. Now you identify the other order pairs in this relation which starts with 2. See, this starts with 2. That means 2 comma 2, 2 comma 3. 2 comma 2, 2 comma 3. What is A comma C? A comma C is 2 comma 3. 2 comma 3 is there in this relation? Yes, here it is. 2 comma 3 is there in this relation. Now I'll check for this one. It ends with 3. You identify the other order pairs which starts with 3. Any other order pair which starts with 3? No. So no need to check with this. Okay. Now come to this order pair. It ends with 2. It ends with 2. Now you check for other order pairs which starts with 2. See here. Here this starts with 2 and this also starts with 2. Okay. this starts with 2 na. This starts with 2 na. You take 1 comma 2, 2 comma 3. 1 comma 2, 2 comma 3. What is a comma c? 1 comma 3. 1 comma 3 is there in this? Yes, it is there. 1 comma 2, 2 comma 2. 1 comma 2, 2 comma 2. What is a comma c? A comma c is 1 comma 2. 1 comma 2 is there in this relation? Yes, it is there. I hope you are understanding what I am saying, right? Now I'll check with this. See, this ends with 3. Is there any other order pair starts with 3? Here, 2 comma 3, 3 comma 3. 2 comma 3, 3 comma 3. What is order pair a comma c? A comma c is 2 comma 3. Order pair 2 comma 3 is there in this relation? Yes, it is there. Okay. Now, you see here, it ends with 3. Now you identify the other order pair which starts with 3. This. That means you take 1 comma 3, 3 comma 3. 1 comma 3, 3 comma 3. 1 comma 3 is there in this relation? Yes, it is there in this relation. So what happened here? It satisfies the transitive property. So when it is transitive, you have to write answer carefully. You see how I written the answer? For a comma b and b comma c belongs to the relation. If I take a comma b and b comma c in the relation, I'll make sure that a comma c is there in this relation. Like that I written this example. I checked like this transitive property. Transitive property holds good for this. So I can say that this relation is transitive. So this relation is symmetric. This relation is transitive but not symmetric. This relation is reflexive, transitive but not symmetric. I hope you understand. This is the one of the best question to try your own. Okay. Now fifth bit. See this fifth bit. Give an example of a relation which is symmetric and transitive but not reflexive. I want you to try your own example such that you can understand this reflexive, symmetric, transitive relations easily. Based on reflexive, symmetric, transitive relation, 1 3-mark question 100% guarantee in final examination. This is easy concept only. This is easy only when you understand all the definitions and with examples, right? Many students, I saw many students, they feel difficulty to understand reflexive, symmetric, transitive property, right? So please try this problem your own. I hope you understand this class. Don't waste your time at home. Practice makes man perfect. Don't lose hope. Stay positive, stay healthy. Thanks for watching this video. Have a great day. Bye bye.